Hi, this is the lesson 6 for P1 OCR 21st Century Science. We're looking in this video about mapping the seafloor, particularly the oceanic ridge, and the idea of seafloor spreading. So in the 1950s, the Americans, the US Navy, paid for a lot of research into magnetic detection. They wanted to be able to use magnetism to detect enemy submarines, and they also wanted to move their own submarines very near to the ocean floor where they could avoid detection, which meant that they spent a lot of time and effort in mapping the sea floor in the Atlantic. What they found in the Atlantic was what's now known as the oceanic ridge. Now, the oceanic ridge happens because of a process whereby magma coming up through the crust, where two plate boundaries are moving apart. So as these two plates are moving apart, the magma comes through and then solidifies on the surface, essentially filling in the gap as the plates move apart. Now, the solid mantle rises slowly, a bit like warm toffee, but as it gets near the top, the pressure falls, and so then we have a melting of the magma to form this liquid magma that comes out of the top. Now, what was discovered when they looked at magnetism of these rocks is that either side of this oceanic ridge, so looking down from the top view, the central line is the oceanic ridge, that either side of the oceanic ridge were effectively different types of magnetism which were symmetrically around the middle. So if this is the ridge at the centre, and effectively if we have a key here, in the white areas and the dark areas, they found that the magnetism was opposite. So in these areas, it might well be that the North Pole was this way, and then in those white areas, the North Pole was in the opposite direction. So where we have a light area, the magnetism of these rocks is in this direction. Where we have a dark area, the magnetism in that way. And they found there was a symmetry either side, which would suggest somehow that the rocks were coming out from the centre. Now, the change in magnetism can be explained away by the fact that the Earth's magnetic field switches every so often. So if you imagine the Earth as a giant magnet with its north and south poles, every once in a while the magnetism would flip and you'd end up like that. Now, when the rock comes to the surface, the magnetism of the rock follows the magnetism that happens to be on the Earth at that time. And then when the rock solidifies, that effectively fixes the magnetism in that direction. And then later, when the magnetism is reversed, the liquid rock that comes to the surface adopts the magnetism whichever happens to be on the Earth at that time, and then when it solidifies, it fixes that direction. And so these stripes of varying magnetic direction in opposite directions being fixed and being symmetrical about the centre suggests that somehow there is rock coming out and moving away from the centre. Now, this was a key piece of evidence, these symmetrical stripes, that backs up the idea that plates must be moving around, in particular in the mid-Atlantic, moving away from each other at roughly a few centimetres per year. But definitely happening. So that's the idea of seafloor spreading. This backs up Wegener's theory, obviously, but obviously it came way too late after he died. So by 1966, this was fully established with the reversing pole directions matching the evidence of these symmetrical magnetic stripes either side of the mid-Atlantic ridge.